Good morning. Welcome all of you back to Microeconomic Theory 2. Today we will learn about Pareto Optimality, competitive game and cooperative game. The Pareto Optimality can be seen as the best solution that the game can yield, or it can be called the win-win situation, or it is the maximized social benefit. Technically, it is defined as a player cannot gain more benefits unless making another player lose some benefits. The competitive game. In the game, each player competes for the best solution for just his or her benefits. No player communicates to each other, and no one cares to calculate the social benefits. However, in cooperative game, each player cooperates with other players for the best solution for all the players. All players communicate to each other, and everyone cares to calculate the social benefits. I will introduce you to game number 4, Prisoner's Dilemma. In this game, we have Agent A and Agent B as players, and we have strategies for them to confess or not confess. Both agents are secret agents and working for our country. They are working in another country and search for secret information. They are arrested and separated to different rooms. The officers of that country ask whether they are secret agents or not. They have two choices: confesses or doesn't confess. However, the payoffs of the answers are very different. If both of them confess, then the other country will know that they are secret agents, and the punishment for the secret agents are heavy. They must be punished by minus 500 U-tunes. Yeah, very heavy punishment. Both of them will lose 500 U-tunes if both of them confess. However, if both of them don't confess, they must still be punished because they access to some secret places and do something strange and try to search for some secret information which is prohibited by law. Therefore, the punishment is still there, but not so heavy. Both of them will be punished by minus 200 U-tunes. Here are the payoffs of the choice of not confess. There are options for them. It is very clever for the officers of that country to offer this option. The option is, if one agent confesses, but another agent doesn't confess, the one who confesses will receive a half punishment, which is just minus 100 U-tunes. But the one who doesn't confess will be punished more, which is minus 800 U-tunes. Why? Because one agent confesses that both of them, not just only that agent, but both of them are secret services. Then the other country now knows that both of them are secret services, and the one who doesn't confess must be punished more. What would happen to this game? Can you guess the result? To solve the game, we take a look at the relation function of agent A first. What if agent B confesses? Agent A has to compare between to confess or not confess, which is minus 500 and minus 800. It is a better choice to choose minus 500 over minus 800. Therefore, agent A chooses to confess. This is the first relation function. The second relation function of agent A. What if agent B doesn't confess? Agent A has to compare between minus 100 and minus 200. And here it is clear that minus 100 is the better choice, and agent A chooses to confess. You see that to confess is the dominant strategy of agent A, because no matter what agent B chooses, agent A will always choose to confess. Now we take a look at the relation function of agent B. What if agent A confesses? Then agent B has to compare between to confess and not to confess, minus 500 and minus 800. And it is clear that minus 500 is better. Therefore, if agent A confesses, then agent B confesses too. The second relation function of agent B. What if agent A doesn't confess? Agent B compares between minus 100 and minus 200. And here you will see that again that agent B chooses to confess between minus 100 is better than minus 200. Therefore, the second relation function of agent B. If agent A doesn't confess, agent B confesses. The dominant strategies of agent A and agent B are to confess. And here we see that the matching between the relation functions of both players is the relation function number 1 of each player, which stays in the same cell. And the result is to confess. Here is the Nash equilibrium. The Nash equilibrium takes place in the competitive game. The competitive game is the game where each player competes for the benefits of just his or her side and doesn't care about the social benefits or the summation of the benefits of all players, just for the individual benefits that they care. And here you see agent A confesses and agent B confesses, and the payoffs, both of them are heavily punished by minus 500 U-tunes. This is the Nash equilibrium in competitive game. However, you see another choice and another payoff. If both of them don't confess, they will receive just only the slight punishment, and the payoff is just minus 200 and 200. Here it is a better payoff, compared to both of them confess. This is called the Pareto Optimality, because it is the best solution in this game. It is the win-win situation. Here, Pareto Optimality takes place in cooperative game, if they can cooperate. if they can tell each other, don't confess before the separation to the different rooms. So if they just has a chance to tell each other, don't confess, they will receive Pareto Optimality. You see that it is clear when there is a chance for both agents to communicate, they can turn the competitive to cooperative game, so they can change the payoff. The payoff that differentiates between the win-win situation at the Pareto Optimality and the lose-lose situation when they cannot communicate. So you see that the cooperative game yields the win-win situation, while the competitive game yields the lose-lose situation. And you can see that the Pareto Optimality yields the highest social welfare, which is calculated by the summation of all the payoffs. You can see the green box, minus 200 plus minus 200. The summation of them is just minus 400. Whereas in the red box, so the payoffs of the lowest social welfare, minus 500 plus minus 500, it is minus 1000. So the summation of the payoffs is the social welfare. And here you see that for the cooperative game, it is the maximized social welfare at the Pareto Optimality. But for the competitive game, it yields the lowest social welfare. In technical terms, the Pareto Optimality is defined as a player cannot gain more benefits unless making another player lose some benefits. In a more technical term, a player cannot be better off unless making another player worse off. You see that we have the jargon better off and worse off. Here you see that agent A can gain more from minus 200 to minus 100, but he must make agent B lose more from minus 200 to minus 800. Therefore, minus 200 and minus 200 at that point is, by technical definition, the Pareto Optimality. By this example, I will summarize the Pareto Optimality again. Pareto Optimality is the best solution that the game can use, and it is the win-win situation, and it maximizes the social benefit. And by technical definition, a player cannot gain more benefits or better off unless making another player lose some benefits or worse off. And that's what we have learned in this class. Cooperative game is the best game to achieve the Pareto Optimality. Communication is the heart of the cooperative game, and we must find a win-win situation in any set of situations between making decisions. If you study about Ricardo's comparative advantage, you will know about gains from trade, and you see that both countries will be better off and get the Pareto Optimality. I hope that you enjoyed the class today, and I hope you could apply the concept of Pareto Optimality, the competitive and cooperative games in reality. See you next class. 再见 Goodbye สวัสดีครับ